All right, deep inside our power grids, our cars, our gadgets, pretty much everything we use, there's a revolution brewing. You see, the hidden world of power electronics is getting this massive AI-powered upgrade, and today we're going to dive into what that actually means for all of us. So let me start with a question. It kind of sounds like a riddle, right? What in the world connects a giant spinning wind turbine to the smartphone that's sitting in your pocket? Well, the answer is a piece of technology that is no joke, quietly reshaping our entire world.
A huge piece of this puzzle is in your electric vehicle, if you've got one. This tech is what manages the whole flow of power from the battery to the wheels. It's basically what makes modern electric cars even possible.
And it doesn't stop there. It's also right at the heart of our renewable energy grid. Converting that unpredictable power from the sun and the wind into the stable, reliable electricity that our homes and businesses need.
And yep, you guessed it, it's in the charger for your phone, your laptop, pretty much every single piece of modern electronics. The answer to the riddle? It's a technology called power electronics.
So what are these things? Simply put, power electronics are the translators of electricity. They take power from a source, like a wind turbine or a battery, and they convert it into the exact form that a device, like the grid or your phone, needs to use it. They're the essential, silent middlemen in our electrified world.
But here's the thing. For as crucial as they are, traditional power electronics, well, they have their limits. They face some pretty serious challenges that have a real tangible impact on our energy systems.
And the problem is this. Classic power electronics are kinda dumb. They operate on fixed, rigid rules, and that leads to wasted energy, completely unexpected failures, and a design process that is just painfully slow and expensive. This is exactly where AI comes into the picture.
So what's the better way? Well, it's to give our power systems a brain. This is where artificial intelligence steps in, and it starts with control. Instead of just following a simple script, AI can make smart, real-time decisions, moment to moment.
Just look at the contrast here. Classic control, it's like basic cruise control in your car, just holds a speed, that's it. But AI control, that's like having an expert chauffeur who's constantly adapting to traffic, to road conditions, giving you the smoothest, most efficient ride possible. It learns and it optimizes on the fly.
And this isn't just some theory. Research from Applied Energy makes it crystal clear. They found that the ability of AI controllers to adapt to whatever's happening fundamentally improves both the stability and the efficiency of the entire system. It's a game changer.
Okay, so if AI can act as the brain, it can also act as a kind of crystal ball. And what I mean by that is predictive maintenance, using AI to see a failure long before it actually happens. Think about the old way. It's totally reactive. If it breaks, then we'll fix it. That thinking leads to sudden blackouts and really expensive emergency repairs. The AI approach is predictive. It says, hey, that thing is going to break, so let's fix it now. That simple shift means cheaper, scheduled maintenance and a longer, more reliable life for all our infrastructure.
So how does this magic work? It's basically a three-step process. First, the AI gets trained on just tons and tons of historical data and simulations, so it learns what normal looks like and what about to fail looks like. Second, it monitors the live system, 24/7, watching for the tiniest little signs of trouble. And third, it makes a decision, flagging a component for maintenance before it can cause a real problem.
So, AI can control our systems, it can maintain them, but its most profound impact might be in how we build them in the first place. You can think of AI as the ultimate architect, one that's totally revolutionizing the entire design process. The classic design process is, well, it's slow. It's this long, iterative cycle of trial and error, building physical prototypes, testing them. AI automated design, on the other hand, just runs millions of virtual prototypes in a simulation to find the absolute best, most optimal solution right from the very start. And the benefits are just huge. We're talking way faster development, systems that are perfectly optimized for efficiency, size, and cost, and the ability to find the single best design out of literally millions of possibilities. Reliability isn't an afterthought, it's built in from day one.
Now, I have to stress, this isn't science fiction anymore. This isn't just theory. These concepts are moving from the lab into the real world, and they're doing it fast, backed by serious investment and some truly cutting-edge research.
Get this. Researchers are already looking to the next frontier, quantum neural networks.
These incredible systems use the mind-bending principles of quantum mechanics, like qubits that can be both a 0 and a 1 at the exact same time, to solve problems that are just impossible for today's computers.
And just look at the acceleration here. The first kind of basic AI systems were applied way back in the late 80s, but in just the last decade, we've seen the deployment of these super advanced concepts like quantum neural networks and GANs. That's AI that can actually generate new data. The pace of innovation is just staggering.
And this isn't some academic exercise. We are talking about real money being spent to solve real-world problems. $4.5 million.
And that's the funding from the U.S. Department of Energy for just one project out of many. This particular one is all about using AI to help renewables provide better, more reliable services to our power grid. I mean, if that's not a clear signal of where the future is headed, I don't know what is.
Which really brings us to the final crucial question. Our cars, our homes, our entire industries, everything is going electric. So in a world that is becoming completely dependent on the flow of electrons, can we really, truly afford for the systems that manage that flow to be anything less than intelligent?